partial derivatives here, calculus, all right? And we're going to talk about the first partial derivative, talking about gradient. So gradient vector, so anytime we're speaking about gradient in the multivariable functions, so that means we're talking about the first partial derivative of that function. So now we have a question here, which is f of a b equals to sin of a sin of b, which is defined over the range negative pi to pi times negative pi to pi. So now for those who remember your trigonometric functions, so you know what we're talking about here, but if you don't, we definitely, have videos on trigonometry that you can as well watch, okay? So let's go ahead and then see what we have here. So we're trying to find the first partial derivative. So that means what? So we're doing it with respect to each of the variables that we have here, correct? So that means what? So that means we have the first partial derivative of the function f with respect to a, okay? So that is with respect to a, and that means what? So when you come here into the function, which is sin of a times sin of b, so that means your target is a. So again, it's all about targeting the variable that you are dealing with. So sin of a is your target because that's the one that contains the a, correct? So now b doesn't contain the a, so what's going to happen is, we'll see right now, okay? So sin of a, so what's the derivative of sin of a? It's cosine of a, correct? So that's cosine of a, all right? And then how are we going to treat now sin of b? So because there's a multiplication between sin of a and sin of b is going to be a constant, and that constant, it's not going to go anywhere, okay? But whenever we have a plus or minus sign between these functions, then the constant is treated differently. That means the derivative of constant will become a zero. But that's not the case in which we are here. So let's go back here and then see. So because of the product, multiplication between these two functions, so the sine b will be taken as a constant, and then that would stay. So that will be then sine b, all right? So, and this is the final answer for this one, all right? But we are not finished because we have to find the partial derivative for the function with respect to b as well. So what does that mean? So here we are now with respect to b, okay? So these are the notations. So that's with respect to b. So if that's with respect to b, so what's going to happen? So once we look at our function here, again, which is sin of a times sin of b, so that means our target is sin of b because that's the one that contains the variable b, all right? Because we're doing it with respect to b. So this is the one that we focus on first to find the derivative for. So what's the derivative of sine of b? Is cosine of b. Now, how are we going to treat sine of a? Sine of a also is going to be a constant, all right? And because of the product between the two of them, sine of a also is going to stay. So we have sine of a times, we said this one is going to give us cosine of b. Okay? So just, we can put it as gradient ab, okay? That will be equal to what? That will be equal to cosine of a sine of b, the first one that we got, okay? And then we associate it with the second answer that we got, sine of a cosine of b, okay? Sine of a cosine of b, and we can put in parentheses, as a couple, all right? So the gradient of a b is cosine of a times sine of b, and then we have sine of a cosine of b, okay, like how we have it here. And this is it, okay? We're done so far. There are some other functions which are more involved, that we're going to see as well, okay?